Hello friends, I hope all are doing well. Welcome to physics class. Already we have started fourth chapter in our IPE, which is the electric charges and fields. Well, in the part 1 we have discussed what is charge, what are the properties of charge, and what are the ways to charge a body. Now in this video we are going to discuss Coulomb's law. We are going to learn Coulomb's law and its vectorical notation. Vectorically, how to write the Coulomb's law. These two things will be discussed now. See, what is Coulomb's law? It is an inverse square law. You are already known inverse square law. Universal law of gravitation is there, where we are saying that two bodies, there is a force of attraction between any two bodies in the universe, where the magnitude of the force is directly proportional to the product of their masses, inversely proportional to the square of the distance between them. Similarly, Coulomb's law also the inverse square law. Here, let us suppose this is a charge. Here one charge is there, Q1. Q1 is a charge. In our previous video we have discussed charge is denoted by Q. Q1 is a charge and here Q2 is another charge. Q1 is a charge and Q2 is another charge. And it is separated by a distance r. It is separated by a distance r. Then there is a force of attraction or repulsion between these two. Yes or no? If Q1, Q2 are the like charges, these two are repelled. If these two are the unlike charges, these two are attracted. There is a force of attraction between these two charges. So the force of attraction which is there, attraction or repulsion which is there between these two is directly proportional to the product of their charges and is inversely proportional to the square of the distance between them. As the distance increases, the force between them will be decreased. So force is inversely proportional to r square. So we togetherly write this as F is proportional to Q1 Q2 by r square. So how to state it? When two charges are separated by a distance r, when two charges, I am writing in the short form, two charges are what happened? Separated. How they are separated? Separated by a distance. Separated by a distance r. Then what happened? There is a force between them. The magnitude of the force. The magnitude of the force. The magnitude of the force. The magnitude of the force is directly proportional to product of their charges and inversely proportional to square of the distance between them. These two togetherly we can write as F is proportional to Q1 Q2 by r square, where we can write F is equals to a constant K into Q1 Q2 by r square. Proportionality constant K. Here now the matter starts. Discussion starts here. What is K? K is 1 by 4 pi epsilon naught. What is this? This is epsilon. This is epsilon. I'll write this one now. This is epsilon. What we can say here? Epsilon. Then epsilon under 1 by 4 pi epsilon naught. Naught. What is this 0? 0 is representing the free space, vacuum. 0 is representing the vacuum to us. 0 is representing vacuum. If you are taking these two charges in any medium, for example, these two charges are in water. These two charges in water. Then we will write here epsilon W. These two are in air. Then we write epsilon air. If these two are in any other medium, then we write that particular medium here. So what is this epsilon? They are saying epsilon 1, epsilon 0, epsilon W, epsilon A. Then what is epsilon here? Epsilon is, I write here, ultimately I write this one 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q1 Q2 by r square. This is what? This is the Coulomb's law. This is Coulomb's law. So what is epsilon naught? Epsilon naught is permittivity. What is epsilon naught? Epsilon naught is permittivity. Permittivity ante enti? What is permittivity? Permittivity is the electric field. The electric field stored in the medium. Stored in the medium. For example, here two charges are there. This is one charge and this is one charge. These two charges are there in one medium. What is there between? Air is there. Okay, between these two charges, air is there. This charge is giving some electric field. So electric field is going from here to here. Okay, now. So when it is giving some 100 electric field, some of this 100 is absorbed by this medium which is there between these two charges. Right? Now here these two charges are in the medium. Right? In any medium. So this medium will absorb some amount of electric field. So that ability of storing some electric field, this is the ability of storing electric field in the medium, is called ability of the medium to store the electric field is called as permittivity. Okay, now the ability here I'll correct it, this one as the ability of the medium to store the electric field. Is the ability of the medium to store the electric field in it is called as permittivity. So what is the value of this epsilon naught in the free space? The value of epsilon naught in the free space 8.854 into 10 to the power of minus 12. 8.854 into 10 to the power of minus 12. What are the units of this? Can you say the units of it? Epsilon naught units I want. See epsilon naught units from here. Can you write? Epsilon naught. Make this epsilon naught as a subject. Epsilon naught need this currently. Force will go to that side. 4 pi is anyhow numerical value, that is there are no units to it. So what are they in the numerator? Q1, Q2. Q1, Q2 are the charges. Charge kone units and identity units. This is 1 coulomb. This is coulomb. Coulomb square. Right? This is R square. R and is distance. Distance is measured in meters. Meter square. This force comes to down in the denominator. So force is what? Newton. So what can I write the units of this one? Its units can be written as Coulomb square per Newton per meter square. Coulomb square per Newton per meter square. This is what the permittivity of the free space or permittivity of the vacuum here. Epsilon naught can be written as 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Okay, means for example, if the charges are of unit charges, I am taking this charge as 1 coulomb, this charge as 1 coulomb. Two charges, 1 coulomb, 1 coulomb. Two charges are separated by a distance of 1 meter. Two charges are separated by a distance of 1 meter. Then what happens? Guess what happens here? F is equals to 1 by 4 pi epsilon naught Q1 Q2 1 into 1 by 1, that is F is equals to 1 by 4 pi epsilon naught, where 1 by 4 pi epsilon naught value is how much? 9 into 10 to the power of 9 newtons. 9 into 10 to the power of 9 newtons. 9 into 10 to the power of 9 newtons. What is 9 into 10 to the power of 9 newtons? 9 into 10 to the power of 9 newtons is the force between the two charges of 1 coulomb and 1 coulomb. Unit charges are separated by a distance of 1 meter. Then the force value is how much? 9 into 10 to the power of 9 newtons. See friends, this is a large force. ఇదంతా హెవీ ఫోర్స్ అంటే ఒక మౌంట్ ఎవరెస్ట్ ను మనము 1 సెంటీమీటర్ పర్ సెకండ్ స్క్వేర్ యాక్సిలరేషన్ తో పుష్ చేయొచ్చు. We can push the Everest with a force with an acceleration of 1 centimeter per second. Such a large force it is. Such a large force it is. F is equals to 9 to the power of 9 newtons. That's why we won't take 1 coulomb. Already in our if you read the textbook, you might have come across 1 coulomb by itself is a very large amount of charge. That is 1 coulomb charge is a large amount of charge. So we'll take always the micro coulombs. Pico coulombs will be considered here. Okay na? మనం ఎక్కువ మన ప్రాక్టికల్ గా వచ్చేది 1 coulomb రాదు మనకు. ప్రాక్టికల్ గా మనకు చాలా తక్కువ అమౌంట్ ఆఫ్ చార్జ్ మనం కన్సిడర్ చేస్తాం. ఓకే, so here we are taking the 1 coulomb, large coulombs, large charges here, so that we are getting a large force of 9 to the power of 9 newtons. అంటే ఓవరాల్ మనం ఏ విధంగా చేసుకోవాలంటే ఇక్కడ coulomb అనేది చాలా large amount of charge. coulomb అనేది చాలా large amount of charge. You have noticed charge of 1 electron. ఒక ఎలక్ట్రాన్ యొక్క చార్జ్ ఎంత ఉంటుంది? 1.6 into 10 to the power of minus 19 coulombs. 10 to the power of minus 19 coulombs వస్తుంది ఒక ఎలక్ట్రాన్ చార్జ్. సో కూలంబ్ అనేది చాలా హెవీ చార్జ్ అనేది మనం గుర్తుంచుకోవాలి ఇక్కడ. ఓకే రైట్. సో దిస్ ఇస్ వాట్ Coulomb's law we call. Force is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. But by using this formula, we can calculate only the magnitude but not the direction. Force is a vector quantity kada. Force అనేది vector quantity. మరి vector quantity అన్నప్పుడు దాని డైరెక్షన్ కూడా మనం చెప్పగలగాలి. But if you have this equation, you can say only its magnitude, but you can't say the direction. To say the direction, we write this Coulomb's law vectorically. How do we write this Coulomb's law vectorically? We'll see it now. Okay, vectorical representation of Coulomb's law. Vectorically, how do we write? See, this is a free space. Okay, free space ఉంది ఇక్కడ. ఒక స్పేస్ ఉంది, ఒక వాక్యూమ్ ఉంది అనుకున్నా, ఏదో ఒక మీడియం ఉంది అనుకున్నా, సంథింగ్. So there I have taken a reference point. This is one reference point. O అనే ఒక రిఫరెన్స్ పాయింట్ తీసుకున్నాను. From this O I have taken a charge Q1 అనే ఒక చార్జ్ తీసుకున్నాను. ఓకేనా? Q1 a charge I have taken. Q1 charge I have taken. Write Q1 down. Q1 charge I have taken here. Okay. The line joining the O and Q1 will show a position vector R1. R1 అనేది ఒక పొజిషన్ వెక్టర్. And at a certain distance, I will take another charge at a R2 position vector. Here I am taking the another charge. I am naming this one as a Q2. Q1 is one charge. Q2 is a another charge. This is Q1 is at R1 distance from O. Q2 is at R2 distance from O. Okay. So what are R1 and R2? R1 and R2 are position vectors. Position vectors representing what? Position vectors representing the position of Q1 and Q2. Now these two charges separate distance, they are separated by distance. Then what happened? You suppose these two are the like charges. Then what it will do? Q1 pushes the Q2, repels the Q2 in this direction. Right? Q2 repels the Q1 in this direction. So force acting on 1 by 2. Force ఎప్పుడైనా ఎట్లా రాస్తాం? F on by. F acting on 1 by 2. Here what the force acting on 2 by 1. Force acting on 2 by 1. Right? Now the vector which is leading Q1 to Q2. The vector leading Q1 to Q2. This is the vector leading Q1 to Q2. Okay, this is R21. I write this one R21. R21 as the vector leading from Q1 to Q2. Vector leading from Q1 to Q2. Where R21 can be written as R1 minus R2. R21 can be written as R1 can be written as R2 minus R1. R21 can be written as R2 minus R1. This is the vector leading from Q1 to Q2. This is direction of the force తీసుకుంటాం మనం. So if it is R21, sir, by direction of force ఇలా అనేది తీసుకోవాలి sir, we can take like this. So let us take like this R12. This is the vector leading from Q2 to Q1. Whatever it may be, magnitude is same. R21 is equals to R12 but opposite in direction. R21 తీసుకున్నా R12 తీసుకున్నా magnitude అనేది same ఉంటుంది. The force which is there between these two is same but only the direction is different. So R21 is equals to minus R2 we will write. Now vectorically how do we write? మనకు కావాల్సింది ఇదే డైరెక్షన్ అనేది ఇదే ఇప్పుడు మనకు. Vectorical notation లో రాయాలి అంటే ఈ R21 అనే వెక్టార్ ని మనం రాయాలి. So how to write the R21 vector? R21 vector. R21 vector. How to write R21 vector? This is a full vector. A full vector can be written as the product of unit vector and its magnitude. ఎప్పుడైనా సరే ఫుల్ వెక్టార్ ఎట్లా రాయొచ్చు మనం ఒక యూనిట్ వెక్టార్ అండ్ మాగ్నిట్యూడ్ ప్రోడక్ట్ గా ఒక ఫుల్ వెక్టార్ రాస్తాం. సో R21 is a full vector. I write this one as a unit vector. R21 unit vector. R21 cap. R21 cap is the R21 unit vector and magnitude of this one R21 vector యొక్క magnitude. So a full vector can be written as R21 R21. Okay, so we can write like this. Now by using this one we can write the unit vector R21 is equals to R21 vector by magnitude of the R21. A full vector by magnitude of the vector. Right? Now we'll go to the Coulomb's law. Once let us come to Coulomb's law. Coulomb's law em నేర్చుకున్నాం మనము. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. దీనిలో ఎలాంటి తేడా రావద్దు. మనం వెక్టార్ నోటేషన్ చూపెట్టాలి కానీ మాగ్నిట్యూడ్ లో తేడా రావద్దు. So we can multiply it by 1. Multiply it by 1. So then there is no change in this. So what we will do here, దీని ఎట్లా రాసుకుంటాం 1 by 4 pi epsilon naught Q1 Q2 by R square where into 1 is nothing but unit vector. So I can write this one as R21 cap. Right, understood? 1 by 4 pi epsilon naught Q1 Q2 by R square R21 cap. This is a vectorical representation of a force. ఇప్పుడు ఏమవుతుంది మనకు ఫోర్స్ యొక్క మాగ్నిట్యూడ్ తో పాటు డైరెక్షన్ కూడా కనబడుతుంది. Or you can write in one more way. This is the one type of writing. Vectorical representation, one type it is. The second type of writing the vectorical representation is F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square into R21 cap. Unit vector ఎట్లా రాసుకోవచ్చు R21 vector by magnitude of R21. Magnitude of R21 అంటే ఈ magnitude అంటే R distance అంటే కదా. Whatever the distance you have taken R, that is this one. So that what happened, already R square ఉంది, దీని వాల్యూ కూడా R. So we can write this one as 1 by 4 pi epsilon naught Q1 Q2 by R cube into R21 vector. Q1 Q2 by R cube into R21 vector. F is equals to. This is another way of representing the what? Coulomb's law vectorically. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R cube R21. మన టెక్స్ట్ బుక్ లో కొన్ని చోట్లలో 1 by 4 pi epsilon naught Q1 Q2 by R cube ఉంటుంది. సరే ఇది ఇన్వర్స్ స్క్వేర్ లా కదా, R స్క్వేర్ ఉండాలి కదా, నో కన్ఫ్యూజన్. R cube ఉంది అంటే పక్కకు మళ్ళీ R21 పైన arrow మార్క్ ఉంది. It is nothing but vectorical representation. Or Q1 Q2 by R square R21 cap ఉంటుంది. ఈ రెండు ఈక్వేషన్స్ ఉంటాయి మనకు. So don't get any confusion if there is R cube in the denominator. If R cube is there in the denominator, then R21 full vector will be represented. If R square is there, then R21 cap unit vector తో రాస్తాం అక్కడ. Okay, this is what vectorical representation of Coulomb's law. ఇందులో ఏం చేసాం, once again we'll revise it. We have taken a reference point. From this reference point, you have taken Q1 is at R1 distance, Q2 is R2 distance, R1 and R2 are the position vectors. Okay, Q1 is applying force on Q2. We suppose here Q1 and Q2 as the like charges. Q2 is applying force on Q1. So F12 is the force on 1 by 2 force on 2 by 1. Force ఎట్లా రాస్తాం ఇక్కడ రాసిన F on by. ఫస్ట్ రాసిన లెటర్ on, నెక్స్ట్ రాసిన లెటర్ by. Force on 2 by 1. Force on 1 by 2. So these two, this is the direction of the forces acting. Now what is the resultant direction of the force? This is the resultant direction of the force R21. So R21, ఈ R21 ని వెక్టర్ ఫామ్ లో రాయాలి అంటే ఎట్లా రాస్తున్నాం, యూనిట్ వెక్టర్ ఇంటూ magnitude. So we will write unit vector as the subject if you take R21 by R21. So here unit vector magnitude, unit vector is nothing but whose magnitude is 1. So its magnitude is 1. In place of 1 I will write this one. So there is no change in this. If I write R21, magnitude change అనేది రావట్లేదు మీకు. So we will write vectorically like this. Okay now, or we will write like this. This is about the Coulomb's law and it's a vectorical representation. Correct? Thank you very much.